for today is basically after yesterday we came up with a list of things that we want to prototype, and each of them have different subsections. Like we have a section for prototyping claws, and we're testing different shapes of claws, and we have groups of 3 to 4 people assigned to each, and each group is going to start today by drawing out some rough sketches, maybe some more detailed sketches, and then doing some CAD if possible, and then maybe working with some parts. We don't have all of our parts here with us today. And then moving forward, we'll continue that prototyping into Tuesday, and by the end of Tuesday we should have everything finalized for what we want to move forward with on the full robot. Yeah. So what we'll do, we're gonna say it stays parallel, right? This is a parallelogram. So when you rotate this moves up vertically, but it stays level to the ground. So if you gear them together, so that you have one gear on this one and one gear on this one, so they move in opposite directions. So like now you basically got this joint powered as well, and now plus 16.
Okay, so we took off 4 wheels off of the original frame, and we're about to build a new frame, but we don't have axles, nor gears, nor bearings, nor
16 and a half.
That's about it. Yeah.
This is a gripper, so I used a wheel for rubber, and it just moves like this side is fixed, and this side moves. But for this one, the wheel just spins, so it doesn't work. But yeah.
We're just looking for parts through what we have, just to kind of get our prototypes done.
Yes. But found another one. There's.
So we're working on the 4-bar design, right? And just to get it started, we need a way for this piece of extrusion to hinge. So we've attached these brackets and then these axle hubs, or actually these are motor hubs, onto it. Then we're putting these 6mm shafts through it, and then they're meant to rotate on it. And then this would be rotating on a channel. So yeah, I'll show you. So this would go in between the channel, and in theory this would work well, but because of the shape of this and the size of the Tetrix channel that we're using, like it collides with the sides and the back of the channel. So if you look at it right here, you can see it would collide with the back of the channel, and we weren't able to get any proper rotation, only like a couple degrees, which was like not enough. So we kind of made this almost makeshift channel by just putting this one piece in between these 2 flat lengths, and then we are doing the axle through like this, the same way we had been doing it before, but now we don't have any obstructions on the side, and we're able to, well, this would be inside. So now you can see how this rotates freely without any obstructions on this kind of side piece. And then we would have another one below this, and then they'd be connected together at this other end with another like channel similar to this, so that it can do the full like parallelogram motion of the 4-bar. And that would be just one side of it. Preliminary 4-bar design. As you can see, we've got it raised up here, so this could be like the base of the robot, and then there would be a motor powering this, which lifts this up, and that would be the first end of it. And then we would have another set of this 4-bar on this side, like right coming off of here with the same rotation, and there would be a gear connecting this to that, and it would need to be an odd number of gears so that this axle's rotation is reversed from this one, and now that would be the double reverse 4-bar design, which would essentially extend up to double of this length and would give us high height while also being very low.
Okay,
just go.
Just like say what we're making. Okay, so we're gonna make like the 2 parallel bars of the 4-bar design, and with this 9-inch what is this called? Bar.
And we do that by taking 2 screws and sliding them inside.
16 millimeters.
16
M3.
And then you have another one.
And then
exact same.
what we do is
And
we
then the other bar, it
take-
would have to be
what
more
is
to
this
the
called?
inward,
This
so it
is-
doesn't like intersect with this.
This is just like a bracket.
That's the linkage that we
This
use
axle
to
also
connect the
rotates
4
while
bars.
this is
And
rotating.
Also, these are
So
all rev
you have
parts.
a gear
Just so
attached
everyone
so that
knows.
they rotate in
And
opposite
then
directions.
we add
Maybe closer to the top,
this
so you'd have a
to the
gear,
bottom
or
2
you just have a gear
holes.
trace that's an even number of
And we
gears,
stick
so
it
it's
out
opposite,
like as much as
opposite,
possible.
and then
So
with
it's
the screw still being
you rotate
inside.
yeah, so it's as long as
and
we
then
can
that
have
one
it.
also extends.
So
out.
kind of like
Now
that.
you would have a lot of height.
Yep.
And then we just screw it in and then secure it with a nut.
36 inches.
It's a 5.
We're done. This is how it
I'm
looks
not
like
done.
at the end.
Good job.
See here, right? This would be like on top of our chassis. It would be a little bit higher because of the wheels, but we like the arm would go up, and you can see we're not quite at the top level, but yeah, when you add in the next one, and if it's at the same angle, it's just over it, which gives us good room to align, but it's also not wasteful and not too heavy or too long, and that's taking up too much space in the rest of our chassis. Obviously, this isn't like our true chassis design. This is just a mock-up to get the height, but yeah. So you can see these dimensions seem to work pretty well, and we're gonna go forward with this for the rest of our prototype.
I'm happy and I approve this message.
Here's what we did today.
So our group, we were working on the double reverse 4-bar design, and we started off by just making a regular 4-bar since that's obviously the first component of it. And as you can see here, you can demonstrate how it works. You spin one of the axles, which will be connected to a motor, and this end moves up, and this is obviously staying vertical, but this is the same length as this side. So we would have another one up here, and we would have gears so that this axle is spinning in the opposite direction as this one, and that would make the lift. And one of the earlier clips showed that we had the height pretty good, pretty well defined, and Tappy will talk about how
Yeah.
we got that.
So basically, this is our parallelogram structure. This is what we're using. Oh yeah, sorry. In order to reach the height that we would need to go, we need 2 sets of these. So, well, yeah, I mean, it would go right here, and I'll explain how to make these and kind of like our process about how we did this in a previous clip. So yeah.
So my group, we created like a claw design. So what this claw is it's basically from the top. There's like some type of grip. In this case, we use like wheels with rubber, and there would be like a motor to help it open and close. But for now, we can just leave it like this. And also, we can you can. So what happens is when the wheels go, when the wheels go around the cone, and obviously a motor would be holding this together so it doesn't fall like that. So it'd be something like this, and you can mount that somewhere on the 4-bar. This is just one claw idea.
That would be.
Yeah.
Oh yeah, that would be at the top.
Okay.
Okay.
So, today I created the cone design. We're using a cone to pick up a cone, so the cone goes inside the cone. So the outside it looks pretty normal. Can I see the cone?
Cone? Cone's on the floor.
Thank you. So we use this cone design on the inside so that, well, one of its properties is it creates room for error. If it goes anywhere, it'll just get it to the center. Inside, on the outside, what I have to do is I have to get a stick through here that'll go up and down linear motion, and that will move 2 tongs that go on the inside. They attach through the inside over here. We just have to drill a hole through that stick and that stick and that stick and that stick, and we put the tongs through there, and it'll open and close like that.
Cool. And do we want to like wrap up and be like, okay. So, this is our end of our day 2 of Robot in a Week. Tomorrow we will be back into our usual facility, and we will have a lot more tools, and we will continue brainstorming, and we hope to be done by brainstorming by Tuesday so we can have actual parts to put on our robot. So stay tuned for tomorrow.
Subscribe to the Frog Forest YouTube channel for daily updates, you know?
And follow us on Instagram and Facebook to see more of what we do.
And Twitter.
Alright, thank you.
That's a good idea. It looks
No,
like
now he looks like
Wait,
a
like this is
Sure.
You know we should.
I'll do like a freeze frame and be like, this is Gautam.
Oh my god, where's the frog? Put the
Put
frog
these in
on
the
his head.
bloopers.
You got it.
So what are you doing CAD design for?
I built a cone that goes around the cone to pick up the cone.
Yeah.
So basically, I'm making like a makeshift channel. Like this.
Yeah.
You wanted the baby.
Y'all, get in the frame.
Huh?
Get in. Get in. We're taking a family picture, guys.
Anshul, stop. Anshul, please.
Please. Are we actually taking a picture?
Okay, ready? 3, 2, 1. And then one with me because I deserve it.
You do.
Yeah.
We do.
Right.
If you want, we can ask my dad to come take a picture.
No, there's a self timer in here. I think.
She's a super fancy camera. She can't take
If only the self timer
This is the one
works.
you're gonna hold still, but- And then